Screencast 20.17, we're asked to calculate the free energy change for an electrochemical cell. So for that, we'll use the free energy formula that involves the standard electromotive force for a cell, E0. And that we need to calculate. But we can do that using standard reduction potentials, right? So in this case, we've got some pure gold solid getting oxidized to 3+ using calcium ions. The calcium ions are being reduced. The gold is being oxidized. And we can balance that out to see that we've got 6 electrons involved in either case, right? So we're going to get the EMF of the cell and then solve for delta G. All right, so this is the standard reduction potential for this that we've flipped around, and then we're going to find the standard reduction potential for the real reduction reaction, which is for the calcium cations, and we'll keep that just like it is. Combining this is going to give a highly negative number, and that means this doesn't sound spontaneous in the forward direction at all, does it? By the way, do not triple these values, just keep them just like they are. And there's other ways to solve this. You could do the reduction potentials of both and subtract the cathode minus the anode. This is another way of doing it. Either way, you get a standard E0 of the cell of negative 4.37 volts, which we're going to plug in right there. N is going to be 6, and F is 96,500, so we're there. Just plug them in. 6 electrons are involved. 96,500 coulombs per mole. And there's the voltage which we calculated, which is negative. Since this is also negative, right, the number of electrons involved, it's a negative value of the number of electrons involved. That's where the negative came from. Negative of a negative is a positive. This is a highly positive value for delta G, suggesting it's not spontaneous in the forward direction, which confirms what we thought all along. This is Screencast 20.16.